everyone, welcome back to our channel Electron Chemistry tutorial. My name is Vijayalaxmi. Now in this video we are going to discuss about qualitative properties of solutions. So this topic is very important for objective. Stay with me till the end. First of all, some important points of qualitative properties. How to define qualitative properties? Actually, physical chemical properties of solution depends on the nature and chemical structure of solute. But some of the properties depends on the number of solute particles but not on the nature of solute. Okay, such type of properties are called qualitative properties. The properties which depends on the number of solute particles but not on the nature and structure of the solute. Okay, so they are called simply qualitative properties. Therefore, relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. Okay, so these are very important properties. Okay, see here in these four properties, elevation in boiling point, depression in freezing point, very important for objective. Okay, in competitive exams 90% question will come from this qualitative properties. Okay, so it's very important topic. Listen to me carefully. So RLVP nothing but lowering of vapor pressure, nothing but delta P. Lowering of vapor pressure, nothing but this is pure solvent vapor pressure, solution vapor pressure. Okay, so in pure solvent surface molecules or solvent molecules, all are can escape into the atmosphere as a vapor. Okay, so vapor pressure is more. But by adding non-volatile solute, some of the solute particles occupies surface area. So automatically solvent molecules decreases. Then escape into the atmosphere as a vapor also decreases. Simply from pure solvent to solution, vapor pressure decreases. So the decreasing vapor pressure from pure solvent to solution is known as lowering of vapor pressure, delta P. So the ratio of lowering of vapor pressure and pure solvent vapor pressure is known as relative lowering of vapor pressure, RLVP. That is equals to mole fraction of solute. Okay, so RLVP is nothing but P0 minus PS, pure solvent vapor pressure, solution vapor pressure, pure solvent vapor pressure, NS by NS plus NR, number of moles of solute by number of moles of solute plus solvent. For dilute solutions, number of moles of solute very less, so that's why NS is ignored. So that's why simply NS by NR only. NS means weight by gram molecular weight of solute, NR means weight of solvent by gram molecular weight of solvent. So also you can take as WS weight of solute, MS molecular weight of solute, W naught weight of solvent, M naught molecular weight of solvent. Okay, so P naught minus PS by P naught is equals to A by M, W by B. Okay, or P naught minus PS by P naught minus PS by P naught is equals to WS by MS into M naught by W naught. So as your wish, you can take this formula, or you can take P naught minus PS by P naught is equals to WS by MS into W naught. Okay, so you can take this formula, you can take this formula as your wish. So based on your clarity, so you can take these two formulas as same. Okay, now relating lowering of vapor pressure is related to the molality of the solution. So molality into gram molecular weight of solvent by 1000. Okay, so then simply how to get this formula? So you can take this formula. Simply here for this formula you can write 1000 by 1000. Okay, simply P naught minus PS by P naught is equals to WS means WS by MS into, so this 1000 right here, 1000 by W naught into M naught by 1000. Okay, so this is what simply molality. So P naught minus Ps by P naught is equals to molality into gram molecular weight of solvent by 1000. Clear everybody? Now delta dB elevation in boiling point. Now listen to me. Elevation in the boiling point, nothing but this boiling point. So first of all, boil. What is the boiling point? The temperature at which, listen to me, the temperature at which vapor pressure of liquids is equals to the atmospheric pressures. Atmospheric pressures. Okay. So the temperature is known as boiling point of that liquids. Okay. The temperature, it will suppose for example at water boiling point 100 degrees Celsius. So means the temperature at 100 degrees Celsius. So vapor pressure of water is equals to atmospheric pressure. Atmospheric pressure. Okay. Boiling point from pure liquids to solutions increases. Why? Because so by adding non-volatile solute, solvent molecules decreases, nothing but vapor pressure decreases. Vapor pressure decreases, nothing but they are not equals to atmospheric pressure. So to increase the vapor pressure to equals to the atmospheric pressure, we need to increase the temperature of the solution. So that's why, so from pure solvent to solution, boiling points will be increases. So that's why that is elevation in the boiling point. Elevation in the boiling point. So is equals to boiling point of solution minus boiling point of pure liquid solvent. So that is also proportional to molality. So the proportionality constant Kb is nothing but elevation in boiling point constant or a bilioscopic constant. A bilioscopic constant. Okay. So Kb. So M nothing but molality formula, weight by gram molecular weight of solute, 1000 by weight of solvent in grams. So these formulas are very, very important for objective. 1, 2, 3, 4. Okay. So these three formulas are also very, very important. Clear? So now let's do some objective bits on these two topics. Okay. So remaining these two topics in next class. Okay. Let's start. First problem. The weight of urea to be dissolved in 100 grams of water to decrease the vapor pressure of water 5%. Okay. Simply lowering of vapor pressure, formula P naught minus Ps by P naught is equals to A by M into W by B. Weight of solute by gram molecular weight of solute, weight of solvent by gram molecular weight of solvent. Okay. Now 5% decreases, nothing but simply here initially 100, 5% decreases, nothing but 95, 100. Okay. Is equals to, we have to calculate weight of urea solute. A molecular weight of urea is the formula of urea, NH2C double bond O NH2. Okay. So one oxygen, each oxygen 16, one carbon, each carbon 12, two nitrogens, each nitrogen 14, 28, four hydrogens, each hydrogen 4. How much? 60. Okay. 60 into weight of water 100 grams, molecular weight of water always 18 grams, 2 plus 16. Okay. Then see here 5 by 100 is equals to A by 60 into 18 by 100. Okay. By this question 5% nothing but we have to write 5 by what? 100. So we have to write directly 5 by 100 or 100 minus 95 by 100. Clear? 100 cancel. A is equals to 5 into 60 by 18. By simplifying this, we will get 16.66 grams. Okay, next second problem. RLVP of 0.2 molar solution in which solvent is benzene. RLVP is equals to what? Molality into gram molecular weight of solvent by 1000 only. So molality is given as 0.2, gram molecular weight of solvent. Solvent is what? Benzene. So what is the formula of benzene? C6H6. 6 into 12, 72. 6 into 1, 6. How much? 78 grams. 78 by 1000 only. So 78 2 times 156, but 15.6, 1000 will become 10 power minus 3. So this is what? RLVP. Clear? Next problem. The amount of glucose to be dissolved in 500 grams of water. So as to produce the same lowering of vapor pressure as that of 0.2 molar aqueous solution. Simply, glucose solution shows same vapor pressure as that of, suppose solution X with 0.2 molar solution. Molar which solution? Aqueous solution. Okay. So lowering of vapor pressure of these both solutions are same. Okay. The relation formulas RLVP is equals to A by M into W by B. So this is for maybe glucose. Okay. For X solutions, same RLVP is equals to, write the relation formula with molality. Molality into gram molecular weight of solvent by 1000. Okay. So both X solution, glucose solution, RLVPs are same. So these two also same. Therefore A by M into W by B, that is equals to M into gram molecular weight of solvent by 1000. Okay. Now A means weight of glucose we have to calculate. Gram molecular weight of glucose, how much? C6H12O6. How much ma? 180. 180. Into weight of water 500 grams. Weight of gram molecular weight of water 18 grams. Now molality is given as 0.2 of aqueous solution into gram molecular weight of that aqueous solution. Aqueous means water, 18 grams by 1000. Okay. Now simplify. 2 zeros, 1 0, 3 zeros. Okay, mutually cancelled. So now 18, 18 also cancel. What are remaining? A 18, 5, here 0.2. That is equal, simply A is equals to 0.2 into 5 into 18. So 0.2 into 5 means 1. So 1.0, 18 grams only. Clear? Okay. Next problem. Fourth problem. This is previous TS 2016. TSMC 2016. Molality of aqueous dilute solution containing non-volatile solute is 0.1 m. M means molality. What is the boiling temperature in degrees Celsius of solution? So Kb is given, boiling temperature of water 100 degrees Celsius. So elevation in boiling point delta Tb is equals to boiling point of solution minus boiling point of solvent. So we have to calculate this. Pure solvent means water, boiling point T0 B is given as 100 degrees Celsius, but delta Tb we have to calculate. Okay. So one more formula for delta Tb. Delta Tb is equals to Kb into molality. So Kb is given as 0.52 ebullioscopic constant. Molality is given as only 0.1. So that is what 0.052. Okay. So delta Tb is calculated as 0.052. Clear? Now we have to calculate TBS, boiling point of solution. Boiling point of solution is equals to elevation in boiling point delta Tb plus boiling point of water. So delta Tb is calculated as 0.052 plus 100. So how much? 100.052 degree Celsius. Clear? Next, fifth problem, Medicine 2013. The boiling point of a solution containing 68.4 grams of sucrose. Molecular mass or gram molecular weight is given as 342 gram per mole. In 100 grams of water is, so we have to calculate what? Simply boiling point of solution. So therefore delta Tb, elevation in boiling point, is equals to boiling point of solution minus boiling point of solvent. So we have to calculate this one. So but we don't have delta Tb also. For calculating delta Tb is equals to Kb into m, molality. Molality value is not given directly, but weight of solute, gram molecular weight of solute, weight of solvent is given. Simply write down molality formula. Kb into weight by gram molecular weight of solute. What is that solute? Sucrose into 1000 by weight of solvent in grams. Solvent in grams. Okay. Now Kb is given as, for water, 0.512 into weight of sucrose is given as 68.4 by molecular weight of sucrose given as molar mass or molecular weight 342 into 1000 by weight of water 100 grams. Two zeros mutually cancelled. So how much? 68.4 into 10 means 684. 684 means 1s, 2s. 0.512 into 2 only. How much? 2 2s are 4, 2 1s are 2, 2 5s are 10. Okay, delta Tb 1.024. Now calculate TBS. TBS is equals to delta Tb plus T naught B. Delta Tb is calculated as 1.024 plus water boiling point always 100 degrees Celsius. Okay, so 100. How much? 101.024 degrees Celsius. Clear? Next, sixth one. This is also previous, Medicine 2009. The molality of an aqueous solution that produces elevation in boiling point of 1 Kelvin at 1 atmosphere. So Kb is for water 0.512. We have to calculate molality. Delta Tb is given as 1 Kelvin. Now Kb is given as 0.512. What is the relation? Delta Tb is equals to Kb into m. No, you have to calculate m. So you have to do it ma. So delta Tb 1, Kb value 0.512. So you have to calculate m. Okay. So write the answer on the chat box. Okay. So you have to do it ma, very simple problem. Homework. Okay. Next problem. Next problem. This is also previous bit, NEET 2016. At 100 degrees Celsius, the vapor pressure of solution of 6.5 grams of solute in 100 grams of water is 732 mm of Hg. If Kb is 0.52, the boiling point of the solution will be. So we have to calculate TBS. For TBS, delta TB is equals to TBS minus TB naught. But we don't know delta TB, elevation boiling point. For that, delta TB is equals to Kb into molality is not given. Write down molality formula. Weight by gram molecular weight of solute into 1000 by weight of solvent in grams. Okay, now Kb is given as 0.52 and weight of solute is given as 6.5 grams. Now, but it didn't give gram molecular weight of solute. Okay, for that, for gram molecular weight of solute, it can be calculated by using the formula relative lowering of vapor pressure, that is P naught minus Ps by P naught is equals to A by M into W by B. M means gram molecular weight of solute. Okay, Ps is given as 732. So what is the P naught? Vapor pressure of pure liquid at standard condition. What I told you, at STP, P naught is equals to vapor pressure of pure liquid, pure water is equals to 1 atmosphere or 760 mm of Hg or 1.013 bar or 760 torrs. Okay, so mm of Hg is given, so that's why you can take a 760 here. Here also 760. That is equals to weight of solute 6.5. Molecular weight we have to calculate. So this relative lowering of vapor pressure also useful for the calculating of molecular weight of molecular mass, gram molecular mass of unknown solute molecular mass. So weight of that water 100 grams, molecular weight of water 18 grams. So by simplifying this, capital M will get 31.7. This value is right here. 0.52 into 6.5 by 31.5 into 1000 by weight of water 100. Okay, 100 grams is given here, weight of water. So two zeros mutually cancelled. 0.52, 6.5 into 10 means 65 by 31.5. So almost 2 times 2.06. 0.52 into 2.06. By multiplying this, we will get 1.07. Okay, now TBS is equals to delta TB plus T naught B. Delta TB is calculated as 1.07. Boiling point of pure water 100 degrees Celsius. 101.07 degrees Celsius. Clear? Next problem. This is also previous bit TS 2015. So this is very simple problem. You have to do it ma. I will give you a hint. So listen to me. An aqueous dilute solution containing non-volatile solute boils at 100.052 degrees Celsius. What is the molality of the solution? Kb for solution 0.52, boiling point of water 100 degrees Celsius. See here, boils at the solution boils at 100.052 means boiling point of solution is given. TBS is given, that is 100.052 degrees Celsius. Boiling point of water also given, TB naught also given 100 degrees Celsius. Okay, now we have to calculate delta TB. TBS minus TB naught. So this minus this. After getting the answer, what is the another relation? For molality, delta TB is equals to Kb into molality. Delta TB is calculated here. Kb is given. So we have to calculate m only. So m is equals to delta TB by KB. Okay, very simple problem. You have to do it ma. Write down the answer in the chat box. Clear? Next, ninth problem. This is also previous bit JEE 2019. 1 gram of non-volatile non-electrolyte solute is dissolved in 100 grams of two different solvents A and B. Only 1 gram of non-volatile solute present in 100 grams of A solvent, 100 grams of B solvent, whose abelioscopic constants are in the ratio 1:5. The ratio of elevation in their boiling points delta TBA by delta TBB. Okay. Now, write down formula. Ratio delta TBA by delta TBB. That is equals to KB for A, KB for B solvent. That is equals to molality. Molality is not given. Weight of solute and weight of solvents are given. Simply write down weight of solute by gram molecular weight of solute into 1000 by weight of solvent in grams. Weight of solute for A compound. This is for A solvent. So this is for B solvent. Okay. Now, here a ratio of abelioscopic constant KBA, KBB how much? 1:5 means 1/5. Now, 1 gram of non-volatile solute, gram molecular weight is not given. Again, same solute, gram molecular weight is not given. 1000 by 100 grams of A, 1000 by 100 grams. So this is mutually cancelled. This is also mutually cancelled. What is the ratio of boiling points of the solution? Simply 1/5 means 1:5 only. Clear? That's all for this video. In the next video, we will discuss depression in freezing point, osmotic pressure, and Van't factor. The three topics are very important in this chapter, so don't miss that video. So thank you for watching this video. Did you like this video? Please like, share, subscribe my channel to get more videos. Thanks a lot.